Hi guys, so today we're going to take notes on scatter plots and correlation coefficients. You may decide that it would be better for you to go back and look at the sneak peek that we assigned way back on Friday the 13th on correlation coefficients, and it might help you understand these notes a little bit better, but none of this is very hard. So let's see how we do. So on the top of your page, I'm actually taking my paper this time, and instead of having it be portrait, I'm turning it to landscape because we're going to do a little bit of folding in a little bit. So let's first of all make sure you guys know what a scatter plot is. So on the top of your paper, if you have lead, let's write scatter plot. And all that a scatter plot does is it shows the relationship between two variables on a graph where each ordered pair is an outcome of the data. Okay. You guys probably are pretty familiar with scatter plots. What you're less familiar with, though, is the term correlation coefficient. And it's kind of weird. The algebra letter that they use to represent correlation coefficient is the letter R. That'll probably make more sense when you get into upper level math classes in high school, but you just have to memorize it. So it's like we have slope is M, don't know why, y-intercept is B, don't know why, correlation coefficient is R. So they mention correlation coefficient in your guys' sneak peek, and what it does is it measures the strength and the association of the linear relationship. Okay, so what we're going to do is we're going to kind of create a little foldable. It doesn't have to be perfect, and you can be using the paper in your notebook instead and just create these little sections. It's just going to make it a little bit easier to organize. So the first thing we'll do is I'm just going to take the paper, still in landscape form, and I'm going to fold it in half. And then I'm going to open it up and fold it into the middle. So we've got like the little barn doors again. And fold it again in the middle, into the middle. And then the last thing we'll do is take your paper, keep it like this, and just fold it in half this way. So that we're basically just giving us some nice sections to give notes in or take notes in. Okay, so we open it back up, and we've got 1, 2, 3, 4 columns, and we've kind of got this nice little line down the middle just to help us organize our work. We're going to end up doing just 5 examples of scatter plots. So what we'll do is let's put the first one right, along this line here. So we're going to put just a sketch of an X and a Y axis here. Okay, we'll put another one, and we can kind of use this fold line to help us do it here. Okay, so there's 2 of them. We're going to put one in the middle. And on this last fold line here, we'll put another one. And then we'll squeeze one more in at the very end here. Okay, not perfect, but good enough. Okay, in fact, I'm going to erase this one because it's bothering me because it's really not spaced right. So I'm just going to move it over a little bit so I have a little bit more space. So let's just scoot it over. You don't have to if you're happy with how it looks. Hey, they're your notes, right? And let's move this one over too. If you were in my second period class this year, you know this is exactly how my notes go. And if you have me sixth period, you never have to see me erase because I've done it so many times. My notes are way better. Okay, so I have 1, 2, 3, 4, 5 sketches that we're going to create some correlation coefficient or some scatter plots. Okay, so for the first one, let's label our x-axis on here as mistakes. So write the word mistakes. And our y-axis we'll put score. And put a perfectly linear set of dots with a negative slope, something like this. Okay, so the example for this type of a problem would be the more mistakes I make, on a test, the lower my score. Perfectly linear, right? Each problem's worth 5 points. The more mistakes I make, the lower my score. The next graph we're going to do is in the same idea. It's going to have a negative slope, but it's not going to be perfectly linear. So along our x-axis here, I'm going to make this a little bit longer. I'm going to put time for the x-axis and temperature for the y. So just put time and temp. And for this one, you're going to still put a negative slope to it, but you're going to scatter your points a little bit. They don't have to be perfect like mine, or they can be kind of just in a general trend, but don't make them scattered all over. They're reasonably linear. They're reasonably associated. So an example for this might be as time increases, my French fries get colder. They're not going to get colder by the exact same amount every single second that goes by. But in general, they're just going to get colder. Now we're going to skip over this middle graph, okay? So don't use that one just yet. We're going to come back to that one. Let's go to the fourth one. The fourth one, let's label that the x-axis, put time, and the y-axis, put grades. Okay, and we're going to do a graph similar to the second one, only it's going to have a positive slope. So you're going to put the dots again, kind of random, but with an overall positive trend. And the example for this one might be something like the more I study, the higher my grade. Not perfectly linear, right? If I study an extra hour, that doesn't mean I'm always going to get 4 problems more correct. But overall, we should see a positive trend. The far right one, we're going to do the opposite of what we did for our far left one, and we're going to put perfectly linear positive relationship. So as best you can, put a nice little positive set of dots like that. And we'll put tickets on the X, money on the Y. Example for this one, the more tickets I buy, the more money I spend. Perfectly linear. I buy 1 ticket, it's $5. 2 tickets, it's 10. 3 tickets, it's 15. So it's going to be perfectly linear. So the only one we haven't done is the one in the middle. And this is kind of the fun one to do because you get to do dots randomly all over the place. Wherever you want to put them, just put them all over. No association there at all. And let's put, for the x-axis, let's put exercise. So we could say hours that we exercise. And on the y-axis, we're going to put the word stars. You know, those things in the sky. And an example of this would be the more I exercise, the more stars are in the sky. Clearly, the more I exercise has nothing to do with the number of stars in the sky. But that's a completely unrelated correlation coefficient. There's no connection there at all. So we have random dots all over the place. So we've got definitions up here. We've got a pretty good visual of these different associations we can have. And then let's start assigning some actual numbers to this whole thing. So you're going to take at the bottom of the page here, so you're going to leave, you know, I don't know, maybe an inch or so at the bottom. We're going to put just a solid line all the way across the bottom, and you're going to put a dot at the end of each line. So put a dot here, and a dot here. And he kind of did this in your sneak peek. So this would be the different, the high-low points that you could have for correlation coefficient. The lowest correlation coefficient number you're going to be given would be a -1. The highest would be a +1. Zero's in the middle. Okay. If you have a -1 for your correlation coefficient, it is perfectly linear. Just like the example up here was. Okay. If you have a +1 up here, also perfectly linear. Okay. Let's come up with some other correlation coefficients that aren't -1, 0, or 1. So let's just put a line, roughly around here. That would probably work. And let's say it's -0.80. The correlation coefficient is -0.80. So this means that as 1 increases, the other decreases. Decreases. Not linear though. Okay. But this still has what we would call a strong relationship here. We're going to say this is strong. Okay. If I come all the way up here and I have a positive, let's just say 0.8, we would say that it's also fairly strong up here. The difference here, though, would be that values up here will increase together. But again, not linear. Well, what do we have in the middle? Well, in the middle, this right here would be considered a weak relationship. Okay. The 0 means there's no correlation. The more I exercise, the more stars are in the sky. The values are not linked at all. So before we put this aside and finish up for today, let's just kind of go back and look at what we've got here. We have a definition for scatter plot. It shows a relationship between two variables on a graph where each ordered pair is an outcome of the data. Correlation coefficients, well, these are the numbers. They measure the strength and the association of the linear relationship. They can go from -1, for example, in this case, where it's perfectly linear, but it has a negative slope. This is perfectly correlated. This is also fairly well correlated, but because the dots aren't in a solid line, we would say it's not as strong a correlation. Here, no correlation at all, right? We'd say that would be like a 0, or for sure a 0. Here, we're going to say that they're reasonably correlated also. The more I study, the higher my score. And then at the end here, this would be a correlation coefficient of 1 because it's making a perfectly linear positive slope. And all we did at the end here is we put together kind of like a number line where we can show that correlation coefficients can only be between -1 and +1. You can't have one lower than -1. You can't have one higher than +1. And they range anywhere in between. -1 would be perfectly linear. It just means that as the one number increases, the other is decreasing. Here would be an example of something that's not perfectly linear, but it's somewhat linear. It's still fairly strong. Here, we would have the same thing happening with this 0.8 up here, except it would be a positive association, and as they will increase together, but again, not linear. And then we get weaker and weaker as we get closer to the 0 here. And so therefore, when we finally do get to the 0, whether we're coming from -1 to 0 or +1 to 0, anything in this area is going to show a fairly weak relationship, no correlation. So I hope this is helpful. You need to have these notes copied into your notebook or in a foldable and glued into your notebook by Friday morning, and be ready to work with our TI Inspires. Thanks, guys. Bye.